Welcome back to geometry on two-dimensional area. Now we are going to do some example problems from finding the area of basic figures. So for these first problems, we actually want to find both the perimeter and the area. So this first diagram is a parallelogram. And on this parallelogram, you're going to be given that this length here is 20. And you will also be given that the height here is 15. And our other side right here, we are given has a length of 18. So first off, perimeter is the length around our figures. So here we have 20, 18. This side would also be 20, and this side would be 18. So we would have to take 20 plus 18 plus 20 plus 18. You can simplify that down to whatever process suits you. But either way, you're going to get a perimeter of 76 units. Area is base times height. And here our height would be 15 because that's where our perpendicular is, and our base then would be 20. So to find the area, we would have to take 15 times 20. And when we take 15 times 20, we get an area of 300, and this would be 300 units squared. All right, let's look at our second example. Our second example, we are given this length is 12. This length is 10, and we have a 60 degrees. So first off, we can certainly find the perimeter. This is 12, the opposite side is 12. That's 10, the opposite side is 10. So we have 10 plus 12 plus 10 plus 12, working our way around. So when we add those up, we have a perimeter of 44 units. Now to find the area, we want base times height. Our height right now we don't know. However, we do have this right triangle, and we can use this right triangle in order to help find our height. So recall how we do that. This is 60 degrees, this is 10. 10 is like our 2x side. So if 2x equals 10, we divide by 2, and our x is 5. Our x is this side over here, which is 5, and then our height is x square root of 3. Since x is 5, we say our height is 5 square root of 3. So the area, the base is 12, and then we want to times that by 5 square root of 3. Well, 12 times 5 is 60, so we have to take 60 times the square root of 3, and our area in this case is 103.9 units squared. Next up, we'll be finding the area of this triangle and rounding to the nearest tenth if necessary. So here in this triangle, we are given that this base is 25 meters, and we are given that this height is 10.7 meters. So the area of a triangle is 1/2 base times height, which we are already given both of those. So 1/2 25 times 10.7. And so when we multiply those together, we end up getting 133.75 meters squared. It says round to the nearest tenth if necessary, so you certainly could write this as 133.8 meters squared. But of course, 0.75 we all know is 3/4. So this would also be a perfectly acceptable answer to do 133 3/4. Okay. Our next example is a trapezoid. And here we're given that this is 8 meters, this is 15 meters, and this is 21 meters. So our formula for a trapezoid is 1/2 height times base 1 plus base 2. Now we know all the information, so 1/2 times our height of 8 times our base 1, 15, plus our base 2, 21. So first order of operation dictates we have to do parentheses. So 1/2 times 8. 15 plus 21 is 32. is 36. And so we take 36 times 8 and we times that by half, and the area for this trapezoid is 144 meters squared. Okay, now we have a rhombus. We know it's a rhombus because we see that there are 4 congruent marks here. All right, and some other things that we should remember about rhombus is they always form 90-degree angles, the diagonals do. So here, for this rhombus, I'm going to tell you that the side is 5, and right here, that length is 3. So now we need to find the length of the diagonals. Well, if this is 3, we know that one is 3. So we know one of our diagonals is a total of 6 because 3 plus 3. We need to figure out that second diagonal. Well, because a rhombus forms a 90-degree angle in the middle, we have this is 3, that's 5. We know that this other side should be 4 by the Pythagorean theorem. That is one of our special Pythagorean triples. If you don't remember it, you can do 3 squared plus b squared equals 5 squared. But a 3, 4, 5 triangle is one of those special triangles you should always know. So this other length is 4. So this one is 4. So our second diagonal here would be 8. So the area is 1/2 diagonal 1 times diagonal 2. So 1/2 times 6 times 8 is 24 units squared would be the area of this rhombus. And our last diagram here is a kite. And in this kite, we are told that whole length there is 15 inches. And this whole length here is 31 inches. So to find the area, we would do 1/2 diagonal 1 times diagonal 2. So 1/2 times 15 times 31. And we take 1/2 times 15 times 31, we end up getting 232.5 inches squared. So that is how we use the formulas to find the area of basic figures.